Okay, so looking at the homework, we're going to do number 2 here. So one of the things we need to do, we're asked to find its area. One of the things we need to do to find its area is be really nice to get this full dimension across here. So I'm going to label that X, and we're going to see what we can find there. We have the 24-foot radius of this half circle, and we were given that, or 24 inches. We're given that this here is tangent there with a 1:4 slope ratio. So I'm going to do some cutting on this. I'm going to cut it here. I'm going to cut it here. We know that this angle right here will be the same as this one over here. To find this one here, it's going to be the inverse tangent of 1 divided by 4. 14.04 degrees, you got it. So now, we're going to come back to this triangle right here and use it. 14.04 degrees. We have a hypotenuse of 24 inches. We need both dimensions on this thing. I'm going to call this here A, this one B. How would I find dimension A? Well, we've got the 24, which is our hypotenuse. A is which side? A is the opposite. Hypotenuse and opposite make sine. So we write down our definition of sine. Sine of an angle is the opposite length of the opposite side over the length of the hypotenuse. And let's fill in our info. Our angle is 14.04 degrees. The opposite side, that's side A, which is what we're looking for, and our hypotenuse is 24 inches. Put this over 1, so that's actually just sine 14.04 times 24. So sine of 14.04, make sure you close our parentheses, times 24. We could divide by 1, but it doesn't change anything. 5.82. I got 5.822. That's 5.822 there. Okay. We've got that. Now I need to find this height here, B, which is the adjacent side. So I've got the hypotenuse and adjacent, which makes cosine. So I'm going to write down my definition of cosine. Cosine of theta equals adjacent over hypotenuse. Putting in my information. It's cosine of 1404. Equals the adjacent side, which is side B, over my hypotenuse of 24. So once again, I will cross multiply and divide. Cosine of 14.04, close that parentheses, times 24 divided by 1, doesn't change anything. 23.283. Okay, so now, if this is 8 here, that makes this one in here perfect, 15.283. Which is just this one here minus the 8. Now that we have that, we can come back here and we can look at finding the rest of that triangle. Let me put that up here. This is 15.283. This is my right angle, and this is 14.04 degrees. All I really care about on this one is this piece down here. I'm going to call that side D. So I have the opposite side over here, and I have the adjacent side, which is what trig function? There it is, the tangent. So tangent of an angle equals opposite over adjacent. Plug in 14.04. The opposite side is 15.283. Adjacent side is what I'm looking for. So I'll put this over 1. So now it's cross multiplied. 1 times 15.283, which is 15.283, divided by the tangent of 14.04, close parentheses, and go. 61.115. Now we have that. That would be this distance here. We could add that to the 5.822, and plus the radius, we'd have that full distance. We don't necessarily need the full distance, though. It's not going to help us much for finding our area. But what we do have here, we have 3 pieces right now that we can find the area. We have this one, and this one. So let's find those areas, and then we're going to come back and find the rest. For area 1 here, it's 5.822 times 23.283. 5.822 times 23.283, and of course it's a triangle, so we're going to divide by 2. Gives us 67.777. Figure 2. 8 inches tall by 61.115. So 61.115 times 8. Do we divide that one by 2? Say no. Why don't we divide by 2? Because the full rectangle. You got her. So 488.92. And what do you need?
He was just asking what.
Oh, what you got? Right. Then number 3 here, this is 61.115 by 15.283. So 15.283 times 61.115, and we have to divide this one by 2 because it is a triangle. For 67.010. So we have those 3 pieces. Now back up here. We need to find that piece. That is a sector of a circle. So it's just the area of the whole circle times whatever this angle is here over 360. We can find that angle rather quickly because this is 14.04, which makes this one 75.96 degrees. Which makes this one 104.04 degrees. Right? Mm-hmm. So that area is pi 3.14 times the radius of 24 inches squared times the angle of 104.04 degrees over 360. So 3.14 times 24 squared times 104.04 divided by 360. 522.697. And now we're going to do some adding. So 67.777 plus 488.92 plus 467.010. 0.1 is fine. The extra 0 on the end don't change anything. Plus 522.697. 1546.404. That would be inches squared. The number itself, though, is not squared. How many of you had that? Pi, you didn't actually do that one. You didn't actually do that one, did you? Okay, well then let's take a look at slightly different problem with some trig applications. I'm going to pause here while I draw because, okay, so what we have here is kind of like a barbell, rectangular area in the middle here. Then we got portions of a circle on either end. We're asked to find x, which is the total distance from outside edge of the circle to the outside edge of the other circle, and we're asked to find the total area of this thing. Okay, so where do we go from here?
I would start with the oblique triangles.
Oblique triangles, what are you talking about?
Either diameter, you're going to have to go radius at either end
Okay.
of the circles of the diameter. Yep.
Let's take the center of the circle. We're going to go from there to there. Cut this across here, right?
I'll make that those two right triangles.
Like this?
Yep.
Okay, perfect. We're going to split it in half right there. Because we know that this is basically the chord of a circle across here.
Yep.
And since that's the chord of a circle, if we draw that line to the center, it makes a right angle. It cuts it in half, cuts the angles in half. Basically, we get two triangles here that are exactly identical to that. We know some of the dimensions of that triangle even. This is how much here?
40 millimeters.
40.
15 on the back side.
And this is 15, half of the 30. Good. With that information, this is already not that hard. So, in fact, finding area, I could already find the area of it if I wanted to. But let's find this dimension here for now. How do I find that dimension? You got it. A squared plus b squared equals c squared. And I'm just going to punch it in. I'm going to do the square root of 40 squared, which is the hypotenuse, minus 15 squared. I'm just subtracting because I'm doing this backwards. I got the hypotenuse. I'm looking for one of the legs. So 37.081 millimeters. Now I'm going to do the same thing on the other end. Center. Right her up. This is how much here on the hypotenuse? 32. And this is still 15. I'm going to find that distance there. Second square root, 32 squared minus 15 squared. 28.267. Millimeters. At this point, we have x. Because we've got 80 here, or not 80, 40, plus 37.081, plus 120, plus 28.267, plus 32. We have x. We're all done with it. Area. To find area, we need to do a little bit more work. To find area, you need to know this angle here. How do I find that angle? Well, I know the opposite side, the hypotenuse, which would be what trig function? Sine. So it's going to be the inverse sine of 15 over 40. Giving me 22.02 degrees. Now the only reason I want that one is because I really need this angle here, which would be 360 minus that twice. So it would be 315.96 degrees over here, this angle. That angle is going to be the inverse sine of 15 over 32. Second sine 15 divided by 32. 27.953. Again, I want this angle here, which is going to be 360 minus that one twice. .09. Now we pretty much got it all. Our area, we got 30 by 120 for this rectangle here. Let's do that. Which is going to give us what? 3,600 millimeters squared. Here, we've got 40 by 15. Or not 40 by 15, 37.081 by 15. Now it's a triangle, so we're going to divide by 2, but there's 2 of them, so we're going to multiply by 2. Right? So there's one here, and there's one here. Makes sense. So 37.081 times 15. And I'm not going to bother multiplying or dividing by 2 and then multiplying by 2 because it cancels out. So those two triangles are 556.215. Over here, 15 by 28.267. Of course, they're divided by 2 because it's triangles, but then times 2 because there's 2 of them. Yeah, you could. I'm not actually punching it in the calculator, but I'm writing it down there just to, so if you're looking at it later, you know where it comes from. Yeah. So 424.005. And then I have my two circle parts. So this one here, I'm going to use the 315.96. So that's pi, 3.14, times 40 squared. The radius is 40, right? There's 3.14 times 40 squared times 315.96. There we go. Times 360. Not times 360. I'll correct it. 4409.397. And then the other one is going to be 3.14 times 32 squared. Its angle was 30409. Gives us 2715,997. Well, let's do some addition here. I don't feel like doing that in my head today, so we're just going to punch it in. 3,600 plus 556.215 plus 424.215 plus 4409. Wait, what?
It's not 0.215 on the two.
No, that's 0.005, isn't it? I don't know where that 215 came from. I see where it came from. Come on. There. That make you feel better? It's all about you, Cody. You know that. $27.15 0.997 equals 11,705,614. That is millimeters squared. What do you think? Good stuff?
Don't call man, don't call me.
Okay, so I've got a worksheet I'm going to give you for tomorrow. Like I said, there may or may not be a quiz at some point tomorrow.